Now we have understood how the phasor diagrams can be drawn for individual elements, that is R, L and C, when they are connected across sinusoidal voltage source as a pure element. And also we have gone through the procedure of phasor diagram construction for two element series circuit, that is RL and RC. Now as we understood all this, so we can now proceed further for drawing the phasor diagram of RLC circuit. So this is R, this is L and this is C. So let us consider these three elements are connected across a voltage source and are constructing one series RLC circuit. Now voltage across R can be denoted by VR as we have done earlier. Voltage across L is denoted by VL and voltage across C is denoted by VC. And if the current is considered I, then this I will be equal to IR equal to IL equal to IC. So this will be current passing through the series circuit. So now if we want to draw the phasor diagram of this circuit, so as per the earlier convention, we will also take the current waveform as the reference waveform. So I equal to IR equal to IL equal to IC. So if we want to draw the phasor of voltage drop across R, so we have to draw in the same phase. So VR will be in same phase with the I. VL will be found as a leading vector over the current. So this will be VL. So as we are considering individual element as pure element, so it will be pi by 2. And similarly, the voltage across the capacitor, that is VC, will be also separated by pi by 2 angle, but it will be obtained as a lagging vector. So it will be obtained by the rotation of pi by 2 in clockwise direction, whereas the VL will be obtained by rotating in anti-clockwise direction by an angle pi by 2. So now we got three phasors with respect to current. So these three phasors are voltage across resistor, voltage across inductor and voltage across capacitor. Now we can see that voltage across inductor and voltage across capacitor, that is VL and VC, are in opposite direction. So automatically they will be subtracted from each other. So if its value is VL minus VC, as per the drawing we have taken that VL is larger than VC. So if we take this is VL minus VC, so we will get one resultant vector which will be called as VT, and that VT will have one angle, and this angle is called phase angle for this circuit. So this circuit is called inductance dominating circuit, or simply an inductive circuit That means the resultant voltage, that is Vt, will be leading over the current. So here the phase angle will be controlled by R, XL equal to omega L, and XC equal to 1 by omega C. So all these parameters will be controlling how much phase angle will be produced. Now we will see one series RLC circuit where the capacitor has a value such that the capacitive effect in the circuit is found dominating. So for that we will draw another circuit and we will explain that. Now if we have a similar RLC circuit, but let us consider that the effect of capacitor is dominating compared to the inductor. So L is there for the inductor. L is representing the inductance of the inductor. C is the capacitance of the capacitor. R is the resistance of the resistor. So VR is the voltage drop across R. VL is the voltage drop across L, and VC is the voltage drop across C. Current is passing as I, and I equal to IR equal to IL equal to IC. Now for Phasor diagram we will draw the I equal to IR equal to IL equal to IC, and voltage across resistor will be in same phase, so VR. And now the inductive drop or the drop across the inductor, so VL will be lead over the current, and VC will be lagging behind the I by an angle pi by 2. So now here we have assumed that capacitive effect will be more. So if the voltage drop across capacitor is bigger than the voltage drop across the inductor, then we have to subtract VL from VC. So this will be VC minus VL, and for that we will get one resultant vector which will be obtained in this direction, and it will be the resultant vector for entire circuit, that is VT. And the phase angle between this I and VT will be the phase angle. So this phi will depend on R, XL and XC as we have explained earlier. So here the circuit will be called as capacitor dominating circuit or capacitance dominating circuit, and phase angle will be found or obtained in such a way that the voltage across the entire element will be lagging behind the current passing through all the elements. So this is a capacitive circuit where current leads over the voltage.